Hello everyone. So this is the polynomial regression. It works this way that here you have different points. You can add points or subtract them. So let's add a new point. And notice this is the new point. So the function hasn't calculated yet the polynomial regression state as before. It just looks differently because the chart was contracted in the x-axis. So how you calculate the polynomial regression from this using this new point? You just switch here. You can manually just set the order of the polynomial. For example, fifth order, which means that it is a plus bx plus cx square and so on up to the x to the fifth power. And here you can see the polynomial function. And you can also use the auto function. This is the lowest sum of squares of the square rests. So from first 8th order of polynomial, it just chooses the order of the polynomial which has the lowest sum of the square rests, or 16th. Or so on. And if you want to save it, you can just click save. And then if you restart the device, notice that the function stayed as the new one. Yeah, so this would be it. Let's jump to the code. Okay, so let's get into the examples. In the libraries polynomial regression GUI, there is the first run and the second run. So the reason why you need to run first run differently than the second one is because of the save to eeprom location. So basically the first run is saving data to the location from which all the consequent runs will read after. And you basically shouldn't have garbage data in this location at the beginning. So this is the example, first run. Second run is pretty much the same except the loop part. So it goes this way, that here's the include eeprom, then include the driver library, and this type is the type with all the variables, or all the important variables of the polynomial regression are in this type. So here can be float or double, and coefficients will be also in this type, the same as the point data, x and y. And this is the polynomial regression, and the rest is basically all the things that are used with the screen. And in the setup, there is the setup startup of the screen. Okay, so inside the loop, the polynomial regression comes with works this way, that there's this basic class called calibrate device that holds all the polynomial regression data and the coefficients data, and has functions to calculate the function at the location specified. And on the top of this, there is this GUI, chart GUI class. So the calibrate device class can run on its own. However, if you have valid Adafruit GFX object with the running screen, you can run also the GUI. With GUI or without, you can use this calibrate device anyway. You can, for example, run this only once with the GUI, set it up on the screen, and figure out all the coefficients and the function and so on. And then you can just simply run it without the GUI loading from eeprom the settings that you have saved. So first you should add some points, and then you usually run something like calculate polynomial coefficients, and you can just manually write here 5 coefficients number, right? So it will be in the format of a plus b x plus cx square and so on up to the x to the 5 power. Or you can also write something like find the best coefficient number from first 8 order coefficients. So it will just use the least square of all the rest approach. So basically, after you add those points, you run this calculate polynomial coefficients, and then you save to eeprom, as this is the first run. This is the location of the eeprom, and this is the last location used, which means that if you would manually want to use this eeprom later, then the next empty location will be 201, and the previous empty location 49. So then you start up the GUI and you use this function to add pointer to this calibrate device class, and you recalculate all the GUI and basically everything you need to, and then you draw this chart. And in your main loop you just refresh only this thing, and you will have the working GUI on the screen. So then you can manually tweak everything, you can add points, you can subtract points, you can recalculate the coefficients however you like. And on the next run, I suggest the example number 2. So this is the second example. There's different loop function, and this I will tell you later what is it. So there's also starting up the calibrate device class, and then right after this there is the load from eeprom of this object. So then if you have running screen, because here you can basically check if you have a screen that is working and ready for use, then you can run the GUI and add the sensor object to this thing. It works only for one object, so just keep this in mind. And you recalculate the GUI and draw it. And this is something extra. Here is the screen. So if I select the point and press the add new point button, then by default I have this old selected point x and y's here. However, if the point is not selected and I haven't run this set get current input function yet, and I press the add button, I have here the 2 zeros as the x and y. Let's upload the different sketch where I have set up the set get current input function. So now when I have nothing pressed, but I press the add new point button, then I have the floating number from the pin A15, from the analog red of this pin. So notice that this thing here is the pointer to the function that returns float in this case. And that's basically how you write it. Here's the return value. And all the time where you have the calculated function, which means that you have run the calculate polynomial coefficient function, or you manually press the button, you can get this calculate polynomial add. So you are writing the x point and it is returning the y point. So let's check out the serial monitor from this thing. 31.86. So 15, it will be somewhere in here, and here is around 31. And inside every main loop, you just refresh the GUI with this function, and this would be it.